So I want to have a little talk about like complexity in software and how over time you might start off with a really basic project and it could be really easy to understand and follow along. But as things get larger and more people contribute to the project and you have more pages, more routes, maybe you split up the microservices because you have like 9 developers or 10 developers and you need to be able to manage and deploy these little services and UIs independently, stuff can just become really complex really quick. And I want to say that what I'm going to talk about in this video, like I didn't really plan too hard for it. So if there's anything that I missed or anything that I said wrong, correct me in the comments. Like just leave a comment below and let me know what are some things that you think cause software to be super complex. So here we have like a line of like simplicity to complexity. So when you first start off, like obviously you're going to be probably here. You have a really basic application. You maybe have, 10, 20 pages or something. And most of it's just like a CRUD application. When you make a request, you save some data and that's about it. Maybe you do some validation on it. But as you work on either a larger scale project or a project with more complicated business logics, you can't just simply store an object anymore, right? You might store an object that might trigger an event to send off an email, that might also do something else to trigger and update a bunch of other entities. So you go from like slowly from the beginning of your project, and as time progresses, your software team and your project, if I can find some people here, let's just pretend like this is like the project. So I'm gonna go ahead and like group this stuff together real quick. And as you keep pushing code and as things change, you're always going to creep closer and closer to complexity, right? And I wanted to kind of talk about like what are the things that we can do. Well, I guess let's first talk about like what are the things that cause software to be complex. And this is where I want you to leave a comment if you can think of your own stuff. So I have a kind of a small list of things that might create complexity in projects. And I think it's our jobs as engineers and developers to fight this complexity, right? There's like this rolling entropy to like always move towards complexity. And sometimes it's like not even our fault, right? Sometimes it's just like an inherent fact of building software where the more stuff you add to a code base, the more complex stuff can get. You might have shared code that's used in different modules, and changing one little file could break features in different files as well. So let's just kind of talk through this list. I want to see if we can kind of like understand like what causes a project to reach this endpoint and how do you keep it back towards the front. And honestly, I don't think people really have a great understanding of this because there's always people arguing about like what type of approach to use for structuring your applications, what libraries and frameworks you should use, et cetera, et cetera. Everyone has their own opinion of like what you can do to reduce the complexity. So the first one I have is poor design. So there are like design patterns out there that you can use. I'm not talking about the Gang of Four design patterns. I'm talking more like clean architecture or ports and adapters or hexagonal architecture, where all of your core business logic and your business entities and business rules are kind of in a layer and isolated from your database persistence choice and isolated from your presentation layer choice, right? So usually most applications have a front end, a back end, and then a database, right? So it's good to kind of tier your application into layers. And if you don't do that from the get-go, you're probably going to be able to move really quick. You might have a really high velocity, but you'll reach points in your project where like there'll be a certain business rule that needs to be true or false based on how you set your entities or how you update your data. And you have those rules like sprinkled all throughout your code base because you didn't follow a good pattern of keeping all your business rules kind of in the same layer, right? If you have a bunch of like rules in the front end that are saying if a user is not registered, then don't show this page, that's more of like a business rule, and somehow you need to get that into a business library and import that from the front end if possible to figure out what you should be showing on the front end. That's just a really basic example, but I hope you understand. So coupled code. Coupled code is basically you have different modules in your code base, and in order to change one module, you end up having to change like other modules as well, right? So the more coupling you have going on, the more complex your project becomes, because now you can't just go in and refactor some code to touch one file, you end up touching a ton of other files. And there's a high chance that because all your code's coupled, you might break your entire application from a single module change. So decoupling your code can help get your simplicity back down here because now you have like all these small little independent modules that you can swap out or delete or modify as you need. And there's a very low, what we call blast radius, where it's not going to affect other modules in your code base. So tech debt, this is just like a term that we use for basically you're working on a story and your manager, your project manager, someone is basically trying to get you to finish it as fast as possible and you feel like you're rushed. So you might kind of cut some corners in your code base. Maybe you're skipping out on unit tests. Maybe you're skipping out a functional test. Maybe you're skipping out on a better way to do something. Right, so every time that you skip on making your code better, you're basically introducing something called technical debt to your project, which is going to slowly creep this line over because now your project is more hard to understand, it's more hard to manage, it's not really maintainable. And as developers, I mean, I think it should be our responsibility to allocate some time away to basically focus on reducing any technical debt, and also push back on project managers or push back on the business to say, look, this feature is not ready to be shipped. We still need to change some stuff. We still need to refactor some stuff. If we get this code into production, it's going to be a mess. I know we want to like get features out in front of users and get that feedback and kind of give value to users. But at the same time, if you push that feature and then you move on to a new one, but that feature was like half done or has a bunch of hidden bugs and edge cases that you never thought about, you've just basically added a bunch of tech debt to your system that's going to come back and bite you in the butt. So another one I put is outdated docs. Like, it's important to make sure your documentation is up to date, not only for yourself and other developers, but when people leave your project, which they're going to at some point, and you hire new people, it's going to be very hard to get them up to speed if you're giving them documentation that's out of date. And they're just going to they're going to sit there struggling, trying to run the project, understand how it works, because they're reading old diagrams or old readmes that don't even work anymore. So now you and your dev team has to invest a bunch more time to helping get these new developers up to speed. And it could be that these developers you hire are really great, but just the documentation is so poor because you did not keep it up to date, which I guess kind of goes along with tech debt. I think tech debt is like a global term that you could probably use for a lot of these things. So let's talk about project size. So again, like as you start, like your project's really basic, it's really simple, you have only a couple pages. But as the project grows, you have a lot more modules, a lot more endpoints, a lot more things could potentially go wrong. So that's one thing that I think people try to solve. Like as projects get larger, they try to split up their backends into something called microservices. They try to split up their UIs into micro UIs, just so that instead of having a huge monolithic project, you have these smaller projects that you can deploy, test, maintain, and manage all in isolation and have them just kind of interconnect. Now, I will say that there is some overhead to having microservices and micro UIs because there's a lot more that goes on behind the scenes in terms of like the DevOps and getting this stuff tested and deployed and making sure that they integrate properly and make sure stuff is backwards compatible. You don't want to deploy a new version for service A and then you break service B. So keep that in mind, but there are some approaches that you can take to basically split up your project into smaller projects to help reduce the complexity because your project's just too big of a monolithic project. So team size is another one I put here. So as your project grows in team size, you have different developers that have different ways of solving problems. Maybe they type different code styles. Maybe some like using for loops, some like using for each loop, some like using maps when they shouldn't be using maps for just, I don't know, looping through arrays. So as your team grows, this complexity also grows because now there's a lot more code coming in at a rapid pace. So you need to basically have these checks in place. There's like, if you're using JavaScript, there's ESLint, and I think ESLint can be used for TypeScript as well. There's Prettier that you can use to kind of format your code. There's a ton of other linters that you can run over your shell scripts. There's something called Megalinter you can use, and these are basically in place to check that before a person is allowed to commit code, it follows a certain standard, it doesn't have security flaws, it looks the same as everyone else's code, right? So if you're on a project that doesn't use any type of linters, that doesn't have any type of formatting rules, this complexity is just going to go to the right, because now every time you open up a new file, it looks like it was written by a completely different person. You don't want that. You want every file to look like it was written by the exact same person so that it's very easy to understand. And then also maybe follow some type of like style guide for your code. If you want, I would try to figure out a way to automate any type of styling rules that you have for your team or your project, but anything to try to make the code look consistent and uniform is probably going to help you stay more on the left side of this complexity. So outdated tech, right? So one thing that we have to do on our projects is we need to make sure that we continuously update our packages, right? You might be using NPM, you might have like 100 different dependencies, and there could be security flaws that basically get released or found all the time in those dependencies, and you need to make sure you keep them up to date every week. So as you keep updating these, the more dependencies you have that are out of date, the higher the chance that you're going to run into a really big issue where you have to update. And then when you try to update, everything breaks because you went from like a major version upgrade, which you don't want to do that, especially if you have like some type of timeline or crunch. You don't want to have to like be forced to update your log4j package because it has a huge security vulnerability. And now you spend 3 weeks trying to refactor all your code because you didn't structure it right. You did poor design. You didn't wrap your third-party libraries with some type of humble object or some type of like adapter. And now you have to go through all your code base everywhere you have the logger, do some refactoring. There's a high chance you're going to break everything. So make sure that you're using up-to-date tech. And mainly I should have said like dependencies, but also tech as well. I mean, like as your project grows in size and becomes older, you might be using something like AngularJS, which is no longer really like used or maintained. So at some point you have to put the brakes on and refactor towards a newer piece of technology, mainly because you want to be able to hire people who know how to use this new tech instead of being stuck at on this really old tech that might work perfectly fine for your project, but honestly, like it might be very hard to hire people for it, or people who don't even want to work there because you're using something really old like Backbone.js, etc. So make sure you keep your stuff updated. Maybe like every week, just try to update everything, make sure it all works, especially for security vulnerabilities. All right, so here is a big one in my opinion. So lack of tests. I think a lot of people, there's like a debate about testing and like how much testing you should do, and is testing even useful? I'm on the side of testing is useful, and honestly, if I was on a team that didn't have any tests, I would probably quit that team and find another project. That's just my opinion, right? I do think there is a ton of value in tests, especially as your project size increases and your team size increases. So imagine you join a project, you're brand new to the team, and this project's been around for 4 years, and you're asked to modify some existing functionality and do something different. If you have 0 tests over that code base, you're probably going to feel pretty anxious going through and changing that code, because you might change a module. You have no idea what is using that module. You have no idea what features might be using that module. So the lack of tests can really shove this whole thing over to the complexity side, because you might make a small little change. You deploy it out somewhere like a staging environment, test environment. You test it, everything looks good. Maybe you have a QA team, they test it, everything looks good. You get it deployed to production, and your users just start crashing because there's another edge case, or maybe 3 or 2 other edge cases that you did not think of. And now that module that you changed ended up breaking for all these edge cases. So if you have all these tests that automatically run over your code base and project when you make changes, there's a much higher chance that you're going to find those bugs before you even release them to production. So lack of tests, I think, is a really, really big one. Bad tests as well. So these kind of go hand in hand. Like, you don't want to have not enough tests. But at the same time, if you write way too many tests over your code, especially too many unit tests that are mocking out everything, it makes it very hard to refactor your code, because now when you go and you change your implementation, you're supposed to do some type of like black box testing where you just test the inputs and outputs of a function. But let's be honest, most functions have a ton of side effects in them unless you're doing like pure functional programming. So ultimately, you have to mock out those inner side effects and verify that they're being invoked with the right arguments. So if you have bad tests where you can't easily go into the implementation and change some code around or move something, and if you do change the implementation, but the inputs and outputs are still the uniform, if you have a bunch of tests break after changing the internals of the unit test, that's kind of a code smell that maybe your tests were really brittle and they weren't written properly. Also, like let's say you have a file and you have a test suite of like 10 different functions in that file, and you make a single little change and you expect it to maybe fail 1 or 2 tests, but it ends up failing the entire test suite. That's another big red flag that your tests are too brittle, right? You should be able to change a single piece of functionality and your test should break in a very small way, right? You shouldn't have an entire test failure, and especially if you have like one module you change and then like a bunch of other unit tests fail. If you change one file and then you have like a ton of other unit testing fail, then you probably have some bad tests. Moving parts. So, I mean, I think this kind of relates to like, how do I explain this? So if you worked with Amazon Web Services, what happens is you get into their ecosystem and then you start adopting more and more of their services, right? You might start off with Lambda and you're like, oh, I could use, Kinesis to process my Lambda events. And you're like, oh, let me use like, RDS or one of their, DynamoDB databases. And then you start saying, oh, well, I need to, make this redundant. So I'm going to do a global table and have like an east and west region and have all this data duplicated. So again, this kind of goes hand in hand with project size and requirements. Some projects don't really care if you have like redundancy set up or resiliency set up, right? If AWS S3 crashes one day, is your application going to be resilient? And you might be working on a project that in the requirements say you have to have like 5 nines uptime or 7 nines uptime. So you need to engineer a more elegant solution to support all of that uptime. So that's kind of like what I mean by moving parts. Like the more complex your requirements are, the the more difficult your system is and the harder it is to orchestrate deployments to that system. I don't know if you can even do anything about the moving parts thing. I mean, you can try to find pre-existing solutions. Like I know Amazon has a bunch of stuff that supports blue-green deployments out of the box. You can do like canary releases with Route 53, etc. But basically, if you can find a way to reduce the amount of moving parts in your system as a whole, I think you're going to shift your complexity over to the left. Now, this is going to be a lot harder said than done. Lots of dependencies. I think I already kind of talked about this. Like, if you have too many dependencies, especially if one module depends on a ton of different stuff, then it's very easy to like have stuff go wrong when those dependencies go out of date. They get deprecated, they have bugs in them, and now you have to refactor code everywhere. I'm not going to re-talk on this because I kind of covered it. So yeah, complex requirements. This I kind of talked about that a little bit with the moving parts, but some projects are kind of simple, right? Like imagine you're building a blog application. That's a super simple application. Users can go in and comment on blog posts. Admins can go in and create blog posts. Most of these like endpoint requests are very CRUD-like, and those requirements are very low. Also, like we don't care about uptime. If your blog goes down for 2 days, who cares, right? You might care. Maybe some of your viewers might care, but overall, like it's not the end of the world if your application goes down. Versus, let's say you're like trying to ship something into space, like you're working on the software that launches rockets. You don't want one of those microchips to kind of go bad and then all of a sudden your application just breaks, right? You want to figure out ways to create redundancy in your system so that if one piece goes bad, there's still one or two other backup internal components or system that are going to process on your event. Anyway, I think you kind of get the idea of that. So I'm going to talk about incomplete requirements. So when you're working on software, you might get a task or a story. It might have some acceptance criteria and it might be missing stuff, right? You might start reading the acceptance criteria. It might have one or two things on it. You start implementing a solution that you think meets these acceptance criteria. And then when you give it to your product owner, you kind of get it in front of your users. They're sitting there scratching their head because they're like, this is not what I asked for. And you're like, well, if you go back and read the story, this is exactly what you asked for. I satisfied your acceptance criteria, and that's on you to provide more, concrete acceptance criteria if you want something. So incomplete requirements can kind of shift the complexity over because you basically just implemented a bunch of code in your code base, and that code you implemented was completely wrong. So now you have to go back and figure out a way to either remove that, revert it, or reshape it in such a way that you meet new changing requirements. And those changes in requirements can kind of slowly add tech debt to your system because now you're having to like refactor code. You might have to fight with your PO or kind of argue with your PO or whatever that like we have to spend a bunch of extra time refactoring what we just did because you gave us incomplete requirements or something. But I mean, these are just really simple examples. The last one I put, I mean, there's tons of other things I could probably put here, but the last one, no intellectual control. So intellectual control is like how confident do you feel about the entire system as a whole? If I were to give you a system, could you explain how all the moving parts are working? If you say yes, then you have very, very high intellectual control. If you say no and you only understand like a small subcomponent of the entire system as a whole, then basically your intellectual control is low, right? So the idea is that if you have a huge project and there's not enough documentation, stuff is just really complex. If no one really understands how the whole system works as a whole, then your whole team has no intellectual control. And when a story comes into the pipe saying to implement A, B, and C, you have no idea what that might do to your system. So you just try to implement it and you find out that you can't really implement the story because of the way your database is set up or the way your REST API is set up or your backend is set up or something like that. Or your choice of technology just doesn't support what the acceptance criteria is. And maybe you didn't know that until you start working on the story. So the higher your intellectual control is, the better your team is going to basically allow them to engineer better solutions that are going to be simplistic versus just hacking stuff on, which is going to move you to the complexity side. And sometimes this is so hard to control because like as you have members join and leave your team over the years, you might have entire code bases that are really, really well known by one person. They leave and now you have a kind of a void where no one knows how that piece works, right? So make sure that you cross-pollinate and everyone kind of understands how all these different pieces of the system work together so that if half your team were to leave, you still have another half that has really good control over the system. Yeah, I don't know. If you have any comments about this, like I just want to have a little talk because it's kind of curious to think like as you're working on software, like stuff just sometimes gets really complex over time. And I think a lot of the beginners on YouTube probably don't really even understand a lot of the stuff I'm talking about because they're working on a small like MERN to-do app. But you have to remember that as you have a huge team and a huge project, like there's a lot more that comes into play outside of just learning React or outside of just learning JavaScript, right? There's tons of other terminologies that you have to kind of understand and balance to try to make sure that your project doesn't just go off the deep end of complexity, and try to keep it somewhere in the center or on the left side of the complexity simplicity spectrum. Anyway, I think that's all I want to talk about in this topic. So if you want to kind of comment below, leave me a comment. If you enjoy hearing this type of talk, I could try to think of some other things to talk about that are kind of cool or interesting. But yeah, also be sure to join my Discord if you want to talk to me directly or ask me questions. We have a pretty good community there of developers trying to learn how to code. We have a lot of React questions coming in all the time, a lot of JavaScript questions. Anyway, have a good day and happy coding.